Okay, so I promised that I would show you how to derive the quadratic formula using completing the square. So just a quick recap of what we looked at in the last lesson. Completing the square. Suppose you've got an equation, quadratic equation, that looks something like that. X squared plus 6x plus 3. Then we're going to come up with square, x squared, perfect square, x squared plus 6x plus 9. How do I get, why is that perfect square? You remember, that's because that is x plus 3 squared. Those two things are equal. Because if you were to multiply that out, I'll just do that quickly over here. So, like I said, this is just a quick reminder. Multiply that out first. What's it? First outside, inside, last. So we get x squared plus 6x plus 9. And it always happens that that gets doubled, that gets squared. So, to complete the square, we find it's going to be x squared plus 6x plus 9 instead of plus 3. So I need to say, what do I have to do to get to there? Well, obviously, in this case, I've got to add 6. Do the same on both sides, add 6. So I know that if that is equal to 6, then its factorised form is also equal to 6, and I can go about solving for x. We all did this today, so I'm not going to spend long on it. Take square roots, get x plus 3, plus or minus the square root of 6, and then get rid of the 3, plus or minus the square root of 6, minus 3. What I'm going to do is I'm going to show you how to do that, but instead of using numbers, so here the numbers were 1x squared it was, 6 and 3. We're going to do it in general. 3. This is A, it could be any number. This we call B because it could be any number. This could be called C. So, oops, let's just set the backgrounds with that doesn't work. Set backgrounds black. Okay. So there's our. This is our general quadratic equation. Ax squared plus bx plus c equals 0. And A, B, and C can be any numbers. Any number. Technically, A can't be 0. Then it wouldn't be a quadratic. If there was no x squareds, it wouldn't be a quadratic, and we wouldn't need a formula full stop. We could just use techniques we've seen for linear equations. So, we did this being maths. First thing I'm going to do is get rid of the A by dividing the left and the right of the equation by A. Get 1x squared plus b over a x plus c over a, because everything gets divided by a. 0. 0 divided by a is obviously 0. So that's the first step. Now we can complete the square. I'm going to need to have some kind of thing in a square bracket that when I multiply it out gives me b over a times x. You'll remember from our numerical examples that it's always half. So here it was 6x, and that became 3. So what's half b over a? You should remember that of same as multiply. So half of b over a is b over 2. So that's what's going to go in the brackets. X plus b over 2a. And we have not finished because we've got there's some gaps that are going to need filling in. Okay, because if we were to expand this out, x plus b over 2a, then we can get x squared plus b over ax. That was the whole point, remember? The whole point of choosing b over 2a is so that when you expand it out, it doubles. Plus b squared over 4a squared. Where does that come from? Well, that comes from that is half. Remember that is that squared. Again, remember the relationship between. Just going back, you remember what's the relationship between the 6 and the 9? So it's half it and then square it. Half it and square it. It's exactly the same in the algebraic case. Halving it and then square it. Halving it to get a thing that goes inside the brackets, b over 2a, squaring it to find this extra term that goes on the ends. So now, I need to know how do we change c over a into something like that. I'm gonna go back. I'm gonna go out and give myself a little bit more space. But how can I go from this line? Just copy that. To this line. And when I do that, what needs to be on the other side? Because we haven't addressed what's going to be on the other side of that equation. Well, the easiest thing to do is to get rid of the c over a. We'll do it in 2 steps. Get rid of the c over a. Do that by taking it away from both sides. We get rid of the c over a, left with x squared plus b over x is negative c over a. And then let's put this extra term in. Add the b squared. And as long as I do the same thing, I can add what I want. I'll add that to both sides. And that means on the left I'll get the thing I want. Because I've got rid of the c over a. And then I've added in the b squared over 4a squared. So I've got what I want on the left. What will I get on the right? Well, I've got negative ca on the right. I'm going to add b squared over 4a squared. I've got b squared over 4a squared minus c over a. Now it's easy to lose track of why we're doing all of this. But remember that the whole point is that this left-hand side is now a nice perfect square. Remember, we had it written out before. X plus b over 2a all squared will give me that green side. If you want to square that out, just to double check and do something to simplify, by all means go ahead. So the green side, that nice perfect square. The yellow side I could also do something with. Because what I want to do is I'm going to turn this from two separate fractions into a single fraction using a single denominator. So, what will that single denominator be? Well, it can be 4a squared. If I'm going to make this 4a squared, this one is already 4a squared, so you can think of that as times it by 1. We're not doing anything to it at all. Not just left with b squared. How do I make the denominator 4a squared there? I'm going to multiply it by 4a, top and bottom. It's going to give me 4a squared on the bottom, which is what I want. And on the top, it's going to give me the negative signs here, look. Negative c multiplied by 4a. And this is the first time really where you can see this thing should look familiar because it's part of the quadratic formula. Okay, that's the hard bit. And that's the bit that people are going to maybe need to go over a couple of times in case there's something you don't understand there. And now that we've done that, and we've got a square on both sides, and we've just got one x, just got x appearing once on the left-hand side, I could just rearrange the same as you did in the numerical examples. I'll get rid of the square by square rooting the left and the right. Square root the left, the x disappear to the right. You square root the right. Well, the nice thing here is that the 4a squared, if you square root it, square root of 4a squared, just simply, well, the square root of 4 is 2, and the square root of a squared is a. So I can do the square root of the denominator, it's going to be 2a. This doesn't simplify so nicely, so I'm going to leave that inside the square root. b squared minus 4ac. Don't forget, every square root has a positive and a negative option. 3 3s are 9. Negative 3 times negative 3 is also 9. So there's two possibilities, a positive one and a negative one. And now that should look very familiar. And you can see that x is nearly on its own. We've just got this last one more term that I need to deal with. I can deal with it just by taking it away. Take it away from both sides. And you're left with, on the left, x on its own. And on the right, we've got this. Take away this. Well, actually, we usually write that as the first term. So b over 2a we write first, plus or minus the square root b squared minus 4ac, also over 2a. 2a, that is. And we can do one last little tidy up because they're both 2a already on the bottom. We can write them over a single denominator. 2a. Don't need to do any collective. Don't need to multiply anything because they're already the same. Minus b plus or minus the square root b squared minus 4ac. And that is where that formula comes from. So, we don't just pull these out of thin air mathematicians, maths teachers. It's a step-by-step process, and please feel free to go back and go through it if there's something you don't understand. And also, of course, if you need to ask some questions, oh, that's not what I meant to do. Look at the K-pop I was looking at earlier. Okay, well, I just want to try and stop it now. If you do have any questions or anything you need to ask, please feel free. I'll see you all next lesson.